Welcome back to this session where we are going to understand what actually is the Java virtual machine and how it makes Java platform independent. Before we begin the session, a small disclaimer that I will not be diving into the JVM architecture and how it has evolved over the years, as I feel that is much more advanced and not something which should be a part of a beginner's course. I do have plans to create an advanced course on that same topic where we will be understanding the JVM architecture and its related concepts. This will be a very basic video to give understanding of how JVM helps achieve platform independence. So without further delay, let's get started. I am assuming that you might not have worked on C, C++, etc. But if you have some experience, you are very likely to know that the C compiler directly produces natively executable code. But in the case of Java, it produces something called a bytecode, which is not the same as machine code. JVM tries to read this file, the file which is called the bytecode file, right? Or the class file, and execute or interpret the instructions in this file according to the rules mentioned in the virtual machine specification. Now, to understand what a specification is, just consider that there is a set of implementation rules laid out by a particular organization, which every vendor, let's say Oracle, Amazon, Microsoft, who is interested in creating their own Java virtual machine implementation should adhere to. So now we will go to the next slide. So with that out of the way, hopefully you got some idea of what a specification is and how actually is JVM working. Let us try to understand this slide. The JVM is a process which runs while we try to run the Java code. Once the Java code is done executing, the JVM shuts down. What we see here is the JVM which is currently executing a class file containing the bytecode. And we got this class file from the compiler output when we compiled our Java source file. So the JVM can generate native machine code for, say, a MacBook running on Apple M2 processor, or say a Windows PC running on AMD processor, or maybe even a Linux flavor like Ubuntu running on an Intel processor. The point being, your bytecode is not changing and still you are able to execute your code on three architecturally different systems. That is the power of the JVM and how Java achieves platform independence. The only thing which changes is that you have to get the proper Java runtime environment for the operating system with a particular CPU architecture. Now by CPU architecture, when you let's say download the JDK, you might come across a particular JDK for Windows x86 architecture, Windows x64 architecture. If you are interested in a Linux version, you can go for, let's say, a Linux ARM64 architecture version, or maybe a macOS ARM64 version, and many more. So with that being said, I will jump on to the next slide. So let's summarize quickly. So we have gone through a ton of theory, and to make things a bit more interesting, we will start writing and developing some simple Java programs. And we will be installing a free IDE such as Eclipse in our next session. And the interesting thing about this IDE is that no separate installation of the JDK is necessary, because when the IDE is installing, it is specifically targeted for Java development, and that actually bundles the JDK along with the IDE. So no additional installation will be necessary for the JDK separately. Also, like if you already have this set up on your system, then please feel free to skip the upcoming lecture in the interest of saving some time. So that's it for this lecture. See you in the upcoming lecture. Thank you for watching this.